Hey everybody, it's Doc Copamise. Last time we used VisualSFM to start making a 3D model of the pseudofossil that got me interested in paleontology back when I was a teenager. In VisualSFM, we imported the photographs that we took of the specimen from all those different angles, had it generate a sparse point cloud, and then from there we generated a dense point cloud. Today what we're going to do is take those dense point clouds and bring them into Meshlab to build a watertight mesh. Now, Meshlab is a very powerful piece of software. It's freely available, very powerful, does a lot of different things. There are a ton of algorithms that you can use, and it can be quite daunting once you start going through the menus. You'll just see lists and feature after feature after feature. What we're going to do today is going to be fairly straightforward, so it shouldn't be too overwhelming at this point. Okay, so here we are in Meshlab 2016. Now, I'm going to use Meshlab 2016 throughout most of this. This is the newest version of Meshlab, but I am going to switch briefly to the previous version simply because there's one feature in that I, at this point, like the way it behaves a little bit better than in the 2016 version, and that's mostly because that's what I'm predominantly used to. I've only had this computer for about a month now, and the 2016 version of Meshlab, which came out last December, there was a conflict between my hardware and that software. It was a known bug that had been discussed in some of the forums, but I couldn't use the new version of the software until I got this. So I'm not quite sure how to replicate what I want in this right off the bat. With that said, though, let's open up our project. Before I do anything, I'm going to bring up hit this icon here. This brings up this menu over on the side. This will show us our layers as we work, and it'll bring up our images down in here once we get started. So we go to File, Open Project. Got to find where you stored your project for VisualSFM. This is probably going to be the hardest part of this for me today, since I always make crazy, deep, weird directories. It should be sudo dense. We're looking for this folder, the 00 folder. This is generated when we tell VisualSFM that we want a dense point cloud. When we hit that CMVS button, it creates several folders, and this is the main one we're looking for. Double click on that, and you're looking for a file called bundle RD out. Every time you have it generate a dense point cloud, it's going to do this. Create the same sort of file structure within your root directory, whatever that was that you originally put your files in, and then it'll have this bundle RD out file. So you click on that, that'll bring you up to this. What this is doing is prompting you for a list of the images. We want to double click on list, and this will open up a list of the undistorted images that were stored in that initial part of the generation process for the dense point cloud. So this usually takes about a minute or two to bring up, so I'm going to hit pause while this is going, and we'll come back after that. Okay, so you can see our list of images here, all with those numeric designations that were generated when it undistorted the images. And then we have our first layer here, this 0 model. Now over in our main window, we can't see anything. What we need to do to bring up our point cloud, our sparse point cloud, is to click on this button right here. We do that, and we can see our sparse point cloud right there. So to get it into the center of the trackball, you just hold down the Control key and your left mouse button, drag it up, get it in the center. Then to zoom in, you just use the scroll wheel on your mouse. So you can sort of see the shape. You may remember this from the last time. So now what we need to do is bring in our dense point cloud. So again, we go to File, go to Import Mesh this time, open that. We want to go to the Models folder, and you'll see this naming convention here, option 0001001. And what it does is, as it's building the dense point cloud, it will do it sort of in stages and break it up so no one file is too big. So if, depending on how many points you wind up generating, you might have 6 or 7 of these things. So what you want to do is just select pretty much all of the ones that have this option 00 whatever naming convention. Just hit open. That'll bring those in to our layers list. Let's see it. Progress bar down here, it's still working on it. Okay, so now we've got all of our point clouds open. We can turn off our sparse point cloud. And you can see here is our dense point cloud from last week. Now, if I turn off one, make one of these invisible, you'll see how it's basically the top of the pseudofossil. Bring that back up, turn off the other, and you can see those points are forming the bottom of the specimen. So what we want to do is to combine these into a single mesh. Usually what I like to do before I combine anything is to work with copies. So you go select the layer you want, right click on it, and go to duplicate current layer. That brings that up down there. Go to the next one, duplicate current layer. And then hit shift, Then you want to go turn off the visibility on your originals. Go back down here, right click again, and then say flatten visible layers. You want to check the keep unreferenced vertices box. This is actually very important because if you don't check that, it basically combines the layers but throws out all your points. So you get a mesh with nothing in it. Then hit apply. Let it do its thing. And so now we've got a single mesh that has all of the points of our dense point cloud. So now what we want to do is clean up some of these just wayward points. And this, if you might remember when I was shooting the original pictures, there was a little piece of green paper where there was a bit of a lip sticking up, and it was a circular piece of paper that the rock was sitting on. And what it's doing is it's catching the edge of that paper. So all I have to do is go in, I select this tool here, select vertices, click on that, then drag it up, highlight those points, hit the delete current set of selected vertices button, and there you go. And just keep working through, getting rid of any of the points that you don't want in your model. Okay, so I'm going to use that as the final dense point cloud. I'm going to export this mesh before I do anything else. Just say dense merged. Save it. Let's click OK. Then I'm going to go into the other version of Meshlab, the 1.13. Import mesh. Go back to that same folder. And then what I'm going to do is go to Filters, Surface Reconstruction Poisson, set the octree depth to 12, solver divide to 9, samples per node to, let's do 5. These are your settings you'll kind of need to play with to get a sense of what's going to work best for you. These are kind of about what I use most of the time. Samples per node, I'll change. If you have a really noisy data set and you need to kind of average things out, you'll want to use a bigger number here. A lot of times I don't change it, I just leave it at 1 if I have pretty good data, and that'll give a lot of good detail. And then just hit apply, and it'll take a few minutes to do this. So we will pause and I will come back when it's ready. So that just took probably about 3 or 4 minutes. Bring up this. So you can see we've got both of our meshes. We have, if we turn off our cloud, you can see we've got our model here. It's got some nice detail. You can see there's that crack that was in it, or what looks like a crack. You can see a lot of that surface detail. We do have a couple of places where we've got these kind of knife points poking out. That'll cause some problems. We'll need to clean those up, but that's not hard. So now what I'm going to do is export this again. Export the water type mesh. Just call it the pseudo surface. Save. Okay. Close that and go back to Meshlab 2016. Import mesh, pseudo surface, brings it up, recenter, turn off our dense point cloud. I'm going to get rid of this wonky little spot right here. There's a vertex hidden in there. So if I do that and click this, it should delete it. Giving me a bit of trouble. Okay, so instead, let's try one more time. Okay. So instead, I'm going to select it this way. Come down to where I can see the face. This will allow me to paint on it. Should. Oh. Okay, so this is a very embarrassing mistake. I now know why this didn't work. And this is one of those things in Meshlab that's kind of tricky. It will catch you up and you will not understand what's going on. So what happened was when I went to turn off the dense point cloud, I turned it off, but that selected that layer. And so the layer I'm actually working on and moving around is not selected. So I have to select that, make sure it's yellow. Now if I go up here and select that vertex, it should work. Let's see if there's, yeah, there's that other one right there. Delete that. That should create a couple of small holes. The next thing we're going to want to do is generate a textured surface. And before we do that, see there's a little island floating here. Get rid of that. Before we generate a textured surface, we need to do a little bit of modification or check something on this mesh. And that texturization algorithm, doesn't like non-manifold edges. So what we need to do is go to the selection, under filters, go to selection, go down to select non-manifold edges, click on it, say apply, and then we just delete those. And it should create, yeah, you see there's a hole right there. It'll create a number of holes in your model. There's something odd there. I'm going to delete that. You can see that little vertex right there is causing some problems. That goes away. Okay. So we've got all this stuff that's obviously not right. We've gone and selected the non-manifold edges and deleted those. Now we've got some holes. We need to close those holes, make it watertight again. We're going to go to cleaning and repairing. There used to be an icon for closing holes up in the toolbar here, and that's gotten moved into, or removed, so now it's just a part of the pull down list. I can't quite remember where that was, so I will come back when I find it. Alright, sorry about that. Like I said, still getting a little used to the new version. So if we go to filters, remeshing, simplification, and reconstruction, it's close holes. Say apply. That should take care of all of our little problematic spots. I'm going to save the mesh again before I do anything else to it. And now we're going to create a textured to go over this surface. So we go to filters, go to texture, parameterization and texturing from registered rasters. Click on that. Select the resolution you want the final image to be. I want this to look pretty nice, so I'm going to go with 4096. Rename your texture. I'm going to call it pseudo Pseudofossil. Now I've noticed something in the past where if I put a space in the name of this texture, it doesn't work. Something about that throws everything off, and you get something that just is not right. So I always like to put an underscore whenever I'm using a long file name, and that seems to solve that problem. And that was something I picked up just by trial and error. Hit apply, and this can actually take a while depending on how complex your model is, how many photos you've got going in, and what resolution you selected. So I will hit pause and take a bit of a break while this works. Okay, so there we are with our textured model. That took about 4 minutes. You can see as we rotate it, turn off the trackball, move it around. That's a pretty good representation. It's actually a very good representation of that rock, that pseudofossil. You can see those surface features, those cracks and offsets show up well. So if we wanted, we could then take this water type model and prep it for 3D printing. I'm not going to do that with this model right now, but in a future video I'll take probably a skull or something like that that I've put up for download on Thingiverse and show you how I would get it ready for 3D printing, hollowing it out, cutting it to minimize support, etc. But you can see this is a pretty nice model, digital model, that was made with software that's freely available that anybody can get a hold of using equipment that is not anything fancy. This was just with a point and shoot digital camera. I could have used the camera on my cell phone if I wanted to. So really, this is something that anybody who has access to a computer and some sort of digital camera could go out and do today if you wanted to. So I hope you found this useful. I will continue to post new videos in the near future, but here we are, the rock that got me into paleontology.